Welcome to this complete Kotlin for Beginner course. Whether you are coming from Java or you are very new to Kotlin, this is a very best place to start. Now Kotlin is an official language for Android development, also using which you can develop backend applications, you can also create multi-platform projects and much more. In this course, we will start learning Kotlin from scratch using real-world examples. You will learn Kotlin syntaxes, classes, functions and much more, and all of these things you will learn with the help of real world examples. So for you it's very easy to understand the concepts, and for later you can use this concept in your own projects. By the end of this course you are very confident with your Kotlin skills. You can write your own Kotlin programming to solve some tasks or create your own Android applications very easily. So let's get started with our project and see how we can learn these concepts, this Kotlin programming things very easily by using real world examples.
I think first I'm gonna open my Chrome browser, and in this Chrome browser simply type download Android Studio. Click enter. Simply open up the first link. Click on this download Android Studio Ladybug. You should accept their terms and conditions. So yes, I have agreed all of the terms and condition. Because I'm using here Mac with Apple chip, that's why I'm gonna use this version of their Android Studio IDE. Now click on it and it will eventually start downloading your Android Studio IDE. By the way, I have already installed this IDE into my MacBook, so I'm not going to download this thing. So simply cancel this thing, and when you download Android Studio file and open up into your MacBook, so it will look something like this. Okay, so this is our Android Studio IDE, but in your case you are not having any kind of project because this is the first time that you will open up your Android Studio. So now I am going to create a new project in our Android Studio. So for that, as you can see in here, we have three different buttons: new project, open and clone repository. So leave these two, click on this new project. And here we have a lot of templates. So for the time being, I'm gonna use here empty activity template. Just leave it. If you are not getting what are these things, just leave it, because right now we are only interested in learning Kotlin programming. We are not interested in learning how we can develop Android application. So first we will tackle how we can actually use Kotlin programming to write or to do some stuffs. So simply use empty activity and click on next. You can give your application name. So I'm gonna give the application name Kotlin course, because we are going to learn about Kotlins. That's why I'm using here Kotlin course. You can give the package name, location where you want to save this particular project into your device, and the minimum SDK. So if you are not getting what are these things, just leave it. Simply use the name, which is Kotlin course, and yes, you are pretty much done. Click on this finish and it will create a brand new Android Studio project for you. As you can see in here, it will take little more time for you because in your case you are executing your Android Studio for the first time. So Gradle will download a few things. Due to that reason, it will take little more time comparing to mine. Okay, so as you can see, we have here our app module. By the way, this is called modules. So we have our app modules, and this is called packages. So Kotlin plus Java is a package. Gaur, Himanshu, Kotlin course, UI is also a package. We have here main activity. So this is out of the scope of our playlist, so simply just ignore it. We have here some Gradle script which is actually used to write all of your tasks, and these are used when you are going to create any kind of Android application. But we are not going to create any kind of Android application. We are going to learn Kotlin programming, so just simply leave it. Okay, so let me just stretch this thing out. Okay, so the most important thing that we will use throughout this Kotlin programming playlist journey, which is this terminal. So as you can see here, we have terminal, and this terminal is actually used to print all of your output that you are going to use to show or verify your outputs. So we'll use this thing more often in our playlist. So that's it. This is our first part. In this part, we saw how to download Android Studio IDE in our MacBook, or if you are having Windows ecosystem, you can download that thing in Windows. Flow is pretty much similar. You can download the Android Studio for Windows with the same steps that we were following in here. What is variable in Kotlin? Well, variable is used to store information so that you can use those information again and again in your program execution. So for that, let me create a package for you, and the package name is variable. So package and files will actually use to structure our code base. So we have here variable package, and in this variable package I'm going to create a file, and the file name is also variable. This is not a class. We will discuss what is class later in this video, but for the time being just be with me. Now I want to use here main function. So main function is a starting point of our application for this variable file. Okay, we will discuss what is function and how we can create function later. So let's discuss what is variable. As I told you, variable is actually used to store a piece of information or data values so that we can reuse those values again and again in our program execution. So let's say we want to create a variable. So for that we have two different types of keyword that is used to create variables. So we have here var, we have here val. So let's begin our journey with var, and I want to create variable a. So a represent variable that is used to store certain piece of information. Let's say I want to store here hello world. So type of this thing is string. We will discuss later what is type in Kotlin, but for the time being just be with me. So this is a piece of information that I want to store in my container or variable. So this information will be present in our variable a. Now we can access this variable, and this variable has a value, and the value name is hello world. So let me use here println function and print this information. Execute your function by clicking on this play button. Run variable kt. As you can see, hello world. Because this hello world information is stored in our variable a, due to that reason, when we are printing this a, we are seeing this value hello world. Okay, now let's say I don't want to use here string type, I want to use here number. So now when you execute, you can see we are able to see 4. As you can see, we have a little warning here, and the warning says variable is never modified, so it can be declared using val. So var keyword is actually used when you want to reassign this a value again and again during your program execution. Okay, but in our case we just setting up this a with value 4, but during our program execution we are not changing its value. Due to that reason we are getting this warning. Now let's say I want to reassign this value. So a will now become 5, and there we go. You can see we are not receiving any kind of warning because first we initialize a with 4, then again during our program execution we'll reinitialize this a to 5. Now when you execute this function, you can see now we are able to get 5. So this is the use case of var keyword. So var keyword is actually used when you want to create a variable that is reinitializable again and again during your program execution. We have one more type of keyword that is used to create a variable, which is val. Now val is immutable. That means if you create any variable using val keyword, that means you are not able to reinitialize this variable again and again during your program execution. As you can see, we have a warning in here, and the warning is val cannot be reassigned. Change to var. Remove it and execute it. You can see 4. So this is variable in Kotlin. We have two different type of variables that is used in our Kotlin programming. We have val keyword, we have var keyword, and the main difference between them is one is mutable and another one is immutable. So var is actually mutable, val is immutable. And one more thing, make sure to use your variable name that make more sense, because in future, let's say you want to read your own code base. So in future, maybe if you are not using here proper variable name, it is hard for you to understand your own code base. So due to that reason, always use variable name that make more sense to you. So I'm using here first number, okay, and pass this first number in the println function. This type of naming convention is called camel casing. We have few different types of casing when it's come to giving the variable name. So first we have here snake case, and in snake case we are using first underscore number, and in camel case second is camel case, and in Kotlin programming mostly we are using camel casing. So in camel case this goes something like this, and we have one more casing which is Pascal casing, I believe, and in this we use first number. So these are the cases we have, and you should consider only the camel case when you are writing your Kotlin code. Now we are going to see what is type in Kotlin programming. So for that, let me create package, and the package name is type. In this type I'm gonna create a file, and the file name is again type. We have here main function, and in this main function I'm gonna create a variable, and the variable name is hello, and in this I'm gonna create a string and store this string information into my variables. Now this is a type of string. So in order to create a string, we use here double quotes, and in this double quote you can use numbers, you can use character, it's totally up to you. Eventually all of the things that you have mentioned in this double quote will be represented in a form of string. Let's say I'm using here 1 2 3 4 5 6, it doesn't matter, eventually it will become in any string. Now you can also explicitly mention the variable type. So now hello is only available to store string type in it. So this is what string type is. Next I'm going to show you few number things that you can use to store number into a variable. So I'm using here val int type. So this is my variable name, and I want to store integer type. So integer type is actually used to store numbers that is not in fraction. So you can use here 1, you can use here -1, you can use here 0, but you cannot use here 4.5 because it is an integer type, and integer type is only available to store non-fraction values, and it uses 32-bit. Next we have float type. So this is also used to store numbers, but it is also used to store decimal numbers. So you can store 1f. So if you want to use float type, on that case at the end, or you can say suffix of your number will eventually become f. So we have here 1f, that means it represents value 1. Type of this thing is float, and it uses 32-bit. So you can use this float for 32-bit operation. We have here decimals too, so you can go up to 6 decimal places. For float, you are only able to use 6 decimal places. Next we have here one more type, which is double type, and this is also used to store numbers, but the main difference between float and double is in double you can go up to 12 decimal places. So 1 2 3 4 5 6 7 8 9 10 11 12, and this eventually use 64-bit. So if you want to perform a big calculation, on that case you should use here double. So mostly in our Kotlin programming, when we are dealing with math calculation, then we should use double, and when we want to show this information to our user, on that case we use float because it has only 32-bit, and also we are only able to see 6 decimal places. So due to that reason, mostly in UI we use float, and in math calculation or any other calculation we prefer double. Next we have long type, and by using this long type, actually it uses 64-bit, With integer you are not able to use 64-bit. Let's say you have a big numbers that you want to represent, for example timestamp. Now timestamp has a very big value, so to represent timestamp or something like that we use long type. So and at the end you should use here L to represent that this is a type of long, and this is used to calculate huge tasks. Like with integer you are not able to calculate something big because we are only using 32-bit, but with long we are using 64-bit, and yes, we can represent a very long number with the help of long. And due to that reason, in order to represent timestamp, because timestamp is a very big number, on that scenario we'll use long. So we have these type of types that is actually used to represent number. Next we have boolean type. Type of this variable is boolean, and you can store in boolean with two types of values, either true or false. So basically it has only two P and C. Either you are using true or you are using false. Next we have here character type, and type of this variable is character, and in order to represent character we use single quotes, and in this single quote you can use any character like H, 1, 2, J, it's up to you. So if you are using single quotes and using only one value, which is J in my case, and if you want to use any big string, on that case you should use string. So character is actually used to represent a single character, and in order to represent character we use single quotes. Now let's see how we can use these integer values within this string. Now I want to use these values within this string. Let's see how we can use it. So for that I'm going to create one more variable, and the variable name is created string. Use here double quotes, and in this double quotes I'm going to use hello. So because I want to use this integer type value in here, so to that we use here dollar sign and pair of parentheses, and in this parenthesis we should use our integer type, and at the end I'm using word, and lastly I'm gonna use println function to print this value created string. Now when you execute it, as you can see hello forward. So 4 eventually represent the int type value. Now what will happen if I remove this thing and re-execute my function? On that case you can see hello int type. That means this time this integer type value is not used in here. It simply considered this thing and in a form of a string. So if you want to use some values within your string, then you should use here dollar sign, and when you re-execute it you will receive the value hello forward. One more thing, we have type safety in here. So let's say I'm going to create a variable, and the variable name is string type. Type of this thing is string, and I want to store here integer type, let's say 4. So it is not possible. As you can see we have a warning in here, and the warning is the integer literal does not conform to expected type string. Long story short, you cannot use any other type with string type because it has certain type which is string. So you can only able to store string values within your string type, and due to that reason we are having type safety in Kotlin programming. You cannot assign a value to a different type. You can use this thing within double quotes. Now it is assignable because now this 4 is not integer, it is a string type, and this is why it is possible to assign this value to our string type. Now we are going to discuss what is function in Kotlin programming. So for that I'm going to create a package, and the package name is functions. In this functions I'm going to create a file, and the file name is functions. So first let's use here main function. Now in this I'm going to create a variable, and the variable name is a, and type of this thing is integer. That's why I'm using 2 value. In this variable a we have variable b, and I want to initialize this variable b with 4, and I want to calculate its sum. So for that we use a few operators. We are having here a plus, so plus is an operator. You can use your a plus b and store this information into a variable c, and lastly just simply print this c. Now logically this c will have value of 6 because 2 plus 4 is equivalent to 6, and when you execute it you will get it. Okay, now let's say I want to reuse this logic again and again. So to do that, we'll create function that is used to calculate this thing a plus b and return me the result of that calculation. So for that we are going to create a function that we can reuse. So in order to create a function, we first use fun keyword. Next, we are going to define my function name. So let's say I will call this sum of two numbers. Next, we have a return type. As I said to you, I'm gonna create a function that is actually use these two values and return me the integer type that contains the information about a plus b. So as you can see, we have function. Name of my function is sum of two numbers, and we have return type. Basically, we are expecting from this function that in future it will return me integer type value. Now, because I want to calculate sum, so in order to calculate sum, we require two numbers. So we have to pass these two things in a form of parameter or argument to our function so that it can use those arguments to calculate or perform this operation. So we can use here a type of this thing is integer. Then we have b argument, type of this thing is integer. So now we are able to pass these two values in our function in a form of a and b. Lastly, we are going to write a logic that is used to calculate the sum of these two numbers. So for that, as you can see, we have a, we have b. Simply use here a plus b, and that's it. This is our logic that is used to calculate the sum of two numbers. But the problem is our function is expecting integer type value. Basically, we have to return something in a form of integer so that the error will be gone, that you can see over here. So for that we use a return keyword. Now this return keyword is actually used to return a specific result from your function. So now it's time to use it. So to use this thing, we use here sum of two numbers, and in this sum of two numbers we are going to pass our a and our b. So what it will do, it will take these numbers in a form of argument and write a logic. So this is my logic a plus b. So once it calculates the sum, because we are using a return keyword, it simply return the final result after the calculation. And as you can see, the return type of this function is integer. That means it will return integer type. C is a type of integer that is actually used to store the sum of these two numbers. Now when you execute this main function, as you can see, we are able to see here 6, which is a sum of a plus b. One more thing, it is not like that you are going to use the same name that your variable has. You can actually use here first number, and in place of b you can also use second number. Now you can write logic for this, first number plus second number, and it works. And one more thing, you can also use here first number to mention that this is the first number value. We have here second number value. So this is actually used when you don't want to pass your variable in sequence. So let's say I want to revert this thing and I want to pass my second number first and first number second. So because we are saying to our function that this first number is equivalent to a, second number is equivalent to b, we have no problem. So when you execute it, it will be the same. Now I'm going to show you how you can create a function which will take unlimited number of argument and return you the result. So for that, I'm going to create a function, and the function name is sum of numbers. Because I want to pass here unlimited number of argument, we'll use here var arg, and you can define the name of this var arg, and for my case I'm using here numbers, and type of this thing is integer. It will simply calculate sum of those numbers and return in a form of integer. So use your numbers, and I'm using here sum. So sum is a function which is provided by Kotlin that is used to calculate sum of a lot of numbers, basically more than one numbers. So I'm using this thing and return it. Now let's use sum of number. Remove this sum of two numbers and use here sum of numbers. Because it has variable argument, you can pass here a, then b, then 3, then 4, then 5, then 6, then 7. Basically you can pass unlimited argument in here. Now when I execute, you can see here 6. Now let's say I want to pass here 10. So logically it gives us 16. As you can see 16. So by using this approach, you can pass unlimited argument, and make sure the type of those argument is homogeneous, I mean the same. Now I'm going to show you how you can use higher order function. So the main difference between higher order function is, in higher order function we will pass function as an argument. I think it's a very complex thing for you to understand. So let me create here a function of higher order, and through that I will explain you. So I'm using here a function, and the function name is higher order sum. Okay, and in this I want to pass a and b because it is a higher order function. So in higher order function, in our argument we pass function. So basically higher order sum will contain an argument, and that argument is nothing but a new function. So let's see how we can pass it. I'm going to call this operation. So this is my function name, and as you can see in function we have arguments. As you can see we have these arguments and the return type. So here you have to mention it. So first argument type is integer, second argument type is integer within a small bracket, and the return type. So if you want to point out the return type, you should use your arrow, I mean the dash and the arrow. So return type of this thing is integer. Cool. Now instead of writing our own logic just like we did for this sum of two numbers, this time I want to use operation function to calculate a plus b sum. So for that I'm using here operation, and as you can see, if you want to call a function, we'll use here small brackets. Similarly, because this will represent a function, I can use the same thing. So I'm using here operation and these small brackets. In this you can pass a plus b, and that's it. Because our operation function contains two arguments and eventually it returns integer type. Now let's see how we can use this higher order sum. So use higher order sum, pass your a and b. Lastly, we have here operation. So use pair of parentheses. Now you are going to define its body, right? Because up to this point you are only define its input type and its return type, but you haven't defined the logic that is actually used to perform the calculation. So that logic will be defined in this pair of parentheses, because logic will be defined within our function body, and this pair of parentheses will represent body for this function. We have a comma b. So because we are having two different argument, that's why I'm using here a. So a represent the first integer, b represent the second integer. Now write your logic. So a plus b. Now this operation function will return you a plus b, basically the sum of these two. But we want to return this value or the calculation to my higher order sum. So for that, first just use here integer. Now this integer will eventually become the return type of higher order sum. Because operation is already returning integer type, use here a return keyword, and that's it. Now simply execute your function. As you can see, we are able to see here 6. So let's recapitulate what we did over here. So we are creating a higher order sum function, and in this higher order sum function we have to pass function as an argument. So we have two values, a and b. So a and b will eventually contain the values that we want to calculate the sum of. Next we have argument, and this is not a normal argument, it's a function. So this function has two input, int, and the return type of our higher order sum is integer. Now I'm using this operation. So this operation will eventually contain the logic to perform a plus b summation, and return type of this function is integer. That's why this operation ab will return integer, and that integer we are returning to our higher order sum. As you can see, its return type is integer, that's why. Now what will happen in here? Higher order sum, we pass a plus b, so a plus b goes into this function and pass this a plus b value to our operation, and the operation body will define over here. So logic behind this is a plus b, that's it. So a plus b eventually return the sum of a plus b, which is equivalent to 6. This is a operation function which is actually used to perform the calculation of a plus b. It will return the calculated value, and once we receive the calculated value, we'll return it, and eventually we are getting the 6, which is a sum of a plus b, and this 6 stored in c variable, and c variable we are printing out over here, and we are getting 6, as you can see over here. So this is a higher order function. We have few built-in function that is used to perform these normal operations. So instead of using here a plus b, you can also use here a plus b, and it will do the same thing. Similarly, we have a minus b, so it will simply subtract it. Simply we have here times, so this is actually used for the multiplication. Then we have divide, so this is used for division purposes. So this function is eventually coming up from KOTLIN. You can use these functions too if you want to, but for learning purposes I don't think so this is a good approach to see. Now we are going to discuss what is if else in KOTLIN programming. So for that, first let me create a package, and the package name is if underscore else, and in this if else I'm going to create a file, and the file name is if else. This is a file, and in this file first I'm gonna use my main function. So first I'm gonna create a function, and that function will give us the information about the number, that is a positive number or negative number. So for that I'm gonna create a function, and the function name is check number. Pass your number as a variable. So I'm gonna call this num. Type of this thing is integer, and it will return a boolean. As I told you, a boolean is actually used to represent true or false. So basically, if anything right, it return you true. If anything goes wrong, it will return you false. So let's use here if else condition. So if our number is greater than 0, that means we are seeing or passing a positive number. So simply return here true. Okay, and what this true signifies? It signifies that our number is positive number. Else you can return false, and this signifies that the number that you have been passing in this function is negative number. So let's see how we can use it. Now I'm going to create a variable, and I will call this is positive number. Use function check number and pass your number. So let's say I'm passing here 12. So 12, yes, it is a positive number, so I believe my check number function will return me true. So now at the end I'm gonna use a println function to print is positive number and execute it. As you can see, it returns true, because when we are passing here 12 number in my check number function, it goes first to this condition, and as you can see, number which is 12, and 12 is always greater than 0, and once it is greater than 0, that means we are seeing a positive number, and if this condition is true, then we will execute this code that is present in this pair of parentheses, and in this pair of parentheses we are returning a boolean type that is true, and this is the same type or the value that we are receiving over here, true. So this function will give us true, and simply print ln to see the actual value that we are receiving from this function. Now I'm going to create one more variable is negative number, check number, and this time I'm going to pass here -12 and print ln is negative number. Because it is a negative number, our function will return false. See over here. So when I was passing 12, it gives us true because this is a positive number, and when I'm passing here -12, this is a negative number or integer, that's why it will give us or return us false, because when you are passing -12, this condition will not be satisfied properly. Due to that reason, we will come to this block, and in this block we are only returning false, and due to that reason we are receiving here false. Now let's say I want to create a function which is actually used to tell us whether the person age is greater than 18 or not, and based on that we will decide if the person is adult or minor. So for that, let's create a function is adult, and in this adult you can simply pass number or age. A return type of this function is boolean. Write a condition. So if age is greater than 18, that means yes, it is adult, else return false. So in our previous function check number, I'm using here return keyword 2 times. So if you don't want to use return keyword 2 times, you can simply use return in front of your if else condition, and it will automatically return the last line of your if condition. Similarly for the else condition. Now I'm gonna use this function to check whether the person age is greater than 18 or not. So for that, create a variable is adult and use function is adult, and I want to pass here 20. Yes, 20 is adult. Print ln and use here is adult, and is adult function will eventually return us true. As you can see over here, true, because 20 is greater than 18, that's why it will return true. And if I am passing here let's say 10 and execute it, it will give us false. Alright, so now I'm going to write one more function, and that function is actually used to print the grade of our student. So for that, let's create a function, and the function name is grade students. Pass the marks of the student in the form of integer, and this time I don't want to return anything from this function. So first, if our marks is greater than or equals to 90, in this case I'm gonna print here a message, and the message is grade A. Okay, I mean everyone loves it. Now we have a lot of condition in this if else condition, that's why if you are having more than one condition, then you can use here else if. So first it checks this condition, and if it is not satisfied, then only it comes to this condition, I mean this second condition. Now I want to check if my marks is greater than or equals to 75. In this case I'm gonna print here grade B. Again I want to write one more condition to check. If our marks is greater than equals to 50, then I wanna print here grade C. And lastly, I'm gonna write a else block. So if all the condition fails that you have mentioned on the top of your branches, then it will execute this else. And I'm using here print ln and call this grade F, I mean the fail. Now I'm going to use this grade student function. So for that, first use grade student and pass here 95, duplicate this thing couple of times. Next I'm gonna use here 80. Next I'm use here 65, and lastly I'm gonna use here 15. So first it will print grade A, then it will print grade B, then it will print grade C, and lastly it will print F. So execute it. See over here, first we are passing 95, so 95 marks is greater than 90, that's why we are seeing over here grade A. Next we are passing here 80, so as you can see 80 is not greater than 90, so it will simply jump to the second condition, which is over here. Now 80 is greater than 75, yes it is true, and if it is true it will simply execute this line of code. So once it will execute this line of code, we are going to see grade B. Similarly, we are passing here 65. Now 65 is greater than 90, no it's not, so it checks the second condition. 65 is greater than 75, no it's not, it simply fall to this condition. 65 is greater than 50, yes it is, so it will print here grade C. And lastly I am having here 15. Now if you can see 15 is greater than 90, no it is not, it check the second condition. 15 is greater than 75, no it is not, it check the other condition. 15 is greater than 50, no it is not. So lastly we have this else block. Now it will simply execute this else block. So we are having here grade F. Now we are going to discuss nested if else condition. So let's say I want to create a function, and that function is actually used to tell us whether the number is even or odd, and if the number is negative we shall print number is negative. So for that I'm going to create a function, and the function name is check number type. Pass your number variable in it. So first I'm going to check the number is greater than or equal to 0 or not. That means if number is greater than or equal to 0, that means we are getting positive number. Now I'm going to write one more if condition. So number modulo 2 is equals to 0. So this modulo is actually used to get the remainder. So let's say you are passing here number 3. Now when you are dividing 3 with 2, remainder will be 1. So it will give you the remainder. And if you are passing here 2, so 2 divided by 2 will give us 0 as a remainder. So it is equivalent to 0. And every even number is divisible by 2. So if you are dividing even number with 2, eventually we are retrieving a remainder as 0. So if it is 0, that means number is even. Use here println and call this even number. Else we are having here an odd number, so odd number, right? So this condition will only work if our number is positive, and if our number is negative, on that case I'm gonna print here number which is the past number is negative. So this is the function which is actually used to tell us whether the past number is even or odd or a negative number. So let's use it. Check number type, and first I'm gonna pass here 2. Again I'm gonna use the same function with an odd number. Execute it. So first it gives us even number because as you can see we are passing 2, and when our argument is 2, so argument 2 is greater than 0, that means we come to this block, and in this block we check number modulo 2. So because we are passing here 2, to 2 divided by 2 will give us 0 as a remainder. So yes, this condition satisfies properly, that's why we are going to see even number. Similarly goes for the odd. So when you are passing here 3, so 3 is a positive number, it comes in here and it checks whether it has any remainder or not. So if you are using here 3 modulo 2, we are having a remainder 1, and due to that reason we are going to see odd number, as you can see over here. Lastly I'm going to show you the negative number. Duplicate this thing by pressing Ctrl D and use here -3 and execute it. It will give you number 3 is negative. Now we are going to discuss what is classes and objects in Kotlin programming. So for that, first I'm going to create a package, and the package name is classes. In this classes I'm going to create a file, and the file name is classes. Cool. So let's say you want to represent a box. Now box has a lot of properties, like it has length, width, height, and also it has volume, it has surface area. Basically it has a lot of things. Now if you want to represent a box in your programming language, on that case we'll create classes. Classes is nothing but a blueprint. On top of this blueprint we'll create objects. So if you want to create a class or blueprint of your box, you can simply use your class keyword. Okay, and after that you can give the name of your class. So in my case I'm using here box. Use small bracket. Now in this small bracket you can add the properties of your box. Like in our box we have three things. We have length, width and height. So create a variable corresponding to those. So first we have length, type of this thing is float. Next we have width, type of this thing is float, and lastly we have height, type of this thing is float. So this is our box blueprint, and using this blueprint I will create certain objects that will represent different boxes. So let's see how we can do that. Create a main function and create a new variable. I'm gonna call this variable as box. Now I want to create a box, so use box small brackets, and in this small bracket you can pass the properties of your box. Like in my case length is 12f, width is 12f and height is 12f. Now this is called an object, and this object is used to represent a box that has length this, width 12 and height 12. So this is what class and objects. Class is nothing but is a blueprint, and using this blueprint you can create different boxes or objects. Now we are going to discuss what is this small bracket. Well, this small bracket is called primary constructor. So this is the first function which is executed when you created an object of your box. As you can see, once you are using this pair of small bracket and pass this length, width and height, this will be the first function that will be executed for your class. So this is what we call primary constructor. Now let's say you want to add functionality to your box class. So how can you do that? Let's say you want to calculate its surface area. So this is a functionality on top of our box class. Because all of our blueprint goes into this class, this is a reason we should put our functionality in this blueprint, so that if we create any object, this object has certain functionality. Like you can use this object to calculate its surface area or volume, etc. So for that we will create a function, and the function name is calculate surface area. Return type of this thing is of course float, because all of our variable is a type of float. That's why I am returning here a float. Now I think you knew the formula. So 2 times bracket. So first we will use length into width plus width into height plus height into length. So this will eventually return me the surface area of my box. Now you can use this functionality to calculate surface area of this object, or you can say of this box. Let's see how we can do this thing. So for that you can simply use your object reference, which is box dot. As you can see, now we have a functionality calculate surface area, and this is created by us. Using this you can calculate the surface area. Now simply press enter, and this will eventually return you the surface area for this box. Now I'm gonna simply here use println to show you whether it is working or not. Click on this play button. Here you can see this is our surface area, and if you want to add more functionality you can do that thing very easily by just adding new functions. Now we are going to discuss what is access modifier. So for the time being, if I'm using here box dot length, length is accessible. Now let's say you want to make this length non-accessible from your object. How can you do that? Well, for these purposes we are having access modifier. So first access modifier is private. So if you are using here private keyword before the variable, then this variable is not accessible using your object. As you can see over here, we are not getting any suggestion regarding the length. Now if I'm using here width, it is available because we are not using private access modifier in front of our variable width. We have basically two types of access modifier. We have private, we have public, and by default if you are not using anything in here, it is public. So either you can use private or nothing. So private means you cannot access this variable using your object, and if you are not using anything, that means it is accessible. So this is what access modifier is. Now we will discuss about secondary constructor. So let's say I'm having a variable. By the way, you can create your class member variable within your primary constructor or within your pair of parentheses. So I want to create a color. Okay, so this is my member variable for this class, and I want to initialize this thing. So for that, let's use here secondary constructor. So use constructor keyword. Constructor is nothing but a function, as I already told you, and in this function we have to pass three things. So that three things will actually use to represent length, width and height, because this is present in our primary constructor. And if you are using any secondary constructor, this secondary constructor has responsibility to initialize primary constructor variables. So for that, I'm gonna use here a length, then I'm using here W for width and H for height, and lastly I'm gonna pass the color to initialize my color variable. Now if you want to initialize your primary constructor variables via secondary constructor, on that case just use your colon this, and in this you can pass your length, width and height. So we are getting length in a form of L, we are getting width in a form of W, we are getting H in a form of H within our secondary constructor. Now we are having color. Use here pair of parentheses, and in this pair of parentheses I am going to initialize my color variable. So as you can see, the name of this color and this color is pretty much same. So how can we make differentiator between these two? Well, if you want to make differentiator between these two, you can use here this. So this will point to your class. Now this class has a variable color, so this dot color will eventually represent this color. Now you can initialize this thing with color, and yeah, that's it. We have a problem, and I think the problem is Lateinit modifier. So Lateinit modifier is actually used when you want to initialize your variable lately, right? So on that case you can use here Lateinit variable, and that's it. Now we have two constructor. You can use this constructor to build your box, or you can use this constructor to build your box. So let's use this secondary constructor to build our box. So for that we have length, width and height. Lastly I'm gonna pass the color, so color is red, and this time it uses secondary constructor to build our box. Now I want to print its color, so for that use box, because this is a private Lateinit variable, this is not accessible. So I'm gonna create a function get color, and this will eventually return the color. Now use here box dot color and execute it, but before that remove this box dot width. See, it is red. So this is what primary constructor and secondary constructor. Now we are going to discuss inheritance. So inheritance is a OOPS concept, and this is our first concept that we are going to discuss regarding the object oriented programming. What is inheritance? Inheritance usually used in order to establish parent-child relation. So this is the same relation that your father have with you, and also you are inheriting some properties, something, some functionality from your parents. This is what inheritance is, and same goes for the programming. So now I'm gonna explain you all of the things related to the inheritance with code. So for that I'm going to create a package, and the package name is inheritance, and in this inheritance I'm going to create a file, and the file name is inheritance. Okay, so we have file. Now I'm going to explain you inheritance with a very simple scenario. So let's say you have a car, and you have a bike. Now car and bike both come under one parent, that is vehicle, because car is also a vehicle and bike is also a vehicle. So first thing first, I'm gonna represent a vehicle, right? So to represent a vehicle, as we have already discussed, we'll use class. So class vehicle, and in this vehicle we have two properties. First we have name of this vehicle, next we have speed. Type of this thing is integer. Okay, so we have a basic class. This class name is vehicle, that has two different variables, name and speed of this vehicle. Now in this I'm gonna add some functionality corresponding to this vehicle. So for that I'm going to create a function, and the function name is display detail. So this function is actually used to show the details of our vehicle. So I'm using here println statement, and in this println I'm using vehicle name colon, and I'm gonna print its name. Similarly I'm gonna print its speed. So for that I'm using here speed, and use our speed that is present in our constructor kilometer per hour. So this display detail function is used to display the details of our vehicle. Next I'm gonna create one more function naming start. So this function is actually used to start our vehicle, and in this I'm gonna use println function, and I want to print my name is starting. So basically this vehicle is starting. Okay, so we have a class naming vehicle that has two functionality, display detail and start. Now car is also a vehicle and bike is also a vehicle. Now let's say I want to represent a car. So for that I'm going to create a class naming car. Now in this car we have its name, and also our car has some speed, and lastly we have this seating capacity, because seating capacity of car is different and bike is different. So we have here seating capacity, type of this thing is integer. Now because car is a vehicle, we can inherit some property from vehicle into this car, because car is also a vehicle. So we can use its functionality in this, because as I said to you, car is also a vehicle, and due to that reason we can inherit some properties, some functionality from our vehicle class to this car class. So to do that we'll use here open keyword. Now open keyword is actually used to make this vehicle class inheritable. Now we can use this vehicle in here. So if you want to inherit or extend the behavior of vehicle into your car, you should use here colon, and after that you'll use this vehicle class. As you can see I was using in here. So in this vehicle, as you can see in the constructor, we have two things, name and speed. So simply pass name and speed in this constructor. So name we are getting in from here, speed is also we are getting in here. So simply use name and speed, and that's it. Now you are able to use vehicle functionality. So we have two functionality, display detail and start. So if you want to use vehicle functionality, for that just simply use here override function display detail, but it is not available because these functions are not open. So just use here open keyword, and for the start use open keyword. Now once you type here display details, as you can see now it is available, because you are overriding the functionality of display detail. Due to that reason we are using here override keyword. This override keyword is actually used to tell you that your parent class, which is vehicle in our case, is already have display details, okay, and you want to override this behavior. So let's say you want to do or show some other details which is specific for this car, and due to that reason we are actually overriding the behavior of our vehicle display detail functionality. So for that you can write your own logic, and what this super.display detail will do, basically when you execute this display detail function, it will eventually execute first your parent function display details. Okay, so this super is actually used to refer your parent class. So as you can see, this super will eventually represent our vehicle, and in this vehicle we want to run or execute display detail function, so it will eventually execute this display detail function. Cool. So similarly you can also use start. Now we have a car that has two functionality, and if you write specific functionality corresponding to this car, you can remove this super keyword and you can simply print something else. Let's say I want to print here car name. Okay, and in this car name I'm using my constructor parameter which is name. Similarly for the speed I'm using here speed colon, use your speed constructor variable and kilometer per hour. So this will eventually use our display detail function to print the car details. Similarly, if you want to start this car, on that case you can remove this super.start and use println statement function, and in this function you can simply type car is starting. Cool. So this is what inheritance looks like. So we are pretty much done with a car. Now it's time to create a bike. So for the bike, I'm going to create here a class, and the class name is bike. And in this bike, again, we have name. Type of this name is string. We have here speed of this bike. We have integer. Lastly, we have has sidecar. Type of this thing is boolean because it may be present in your bike or it won't. Now I want to extend this thing with vehicle. As you can see, bike is also vehicle, so due to that reason you can extend the functionality of your vehicle, and in this vehicle you can pass your name and speed, and also you can override the functionality of your vehicle and write the logic corresponding to your bike. So for that you can simply use here display detail override function, remove this super call and use here println, and this time I'm having a bike, so bike name, use your name, and speed of this bike is speed kilometer per hour. And if you want to start your bike, you can simply override the functionality of your vehicle one more time into your bike class. So for that you can simply use your start, remove it, println, and here you can use bike is starting. Cool. So this is what inheritance is. So vehicle is called our base class, and this car class and bike class is called derived class because these are derived using this vehicle class. Now I'm going to create few objects of this car and bike and execute this functionality to see whether it is working or not. So for that I'm going to create here a main function, and in this main function first I'm going to create my car, and in this car first you can see we have to pass name, so I'm going to use here string car1. Okay, so this is my name, and speed is 34 and my seating capacity is 5. So this is my car. Next I'm going to create here a bike object. In this bike I'm gonna give the name of bike is bike1, speed is 56 and has sidecar, so I'm using here false. Okay, so now I'm using my car and display its detail. Similarly I'm using my bike and I want to show its detail, and when you execute it you can see car name is car1 and speed is 34 kilometer per hour. Similarly for the bike, name is bike1, speed is 56 kilometer per hour. Okay, so now what will happen if I use here super call? So super will eventually point your parent class, I mean the vehicle, and when you call display details and execute your main function, as you can see first it will trigger your parent class display details, and after that it will show you the information regarding the car. So vehicle name car1, speed is 34 because we are passing the same name and same speed in our vehicle during the creation of our car class, and due to that reason in both display detail you will see the information which is coming from this constructor to this car. So vehicle name is car1 and speed is 34. Similarly for the car, car name is car1 and speed is 34 kilometer per hour. Now I think the concept is pretty much clear to you. Next we are going to discuss polymorphism. Well, polymorphism means more than one form. So just consider yourself, if you are a man, you are someone's father, someone's husband, or someone's brother. So basically you are a single person, but still you will play different role corresponding to the different persons, right? So this is what polymorphism is. So let's understand this thing with very simple example. So for that, first thing first, I'm gonna create here a package, and the package name is polymorphism. Okay, and in this polymorphism I'm gonna create a file, and the file name is again polymorphism. This is a file, and in this file first I'm gonna create a class, and the class name is animal. Every animal has a sound, so I'm going to create a function naming sound, and I'm going to print here animal makes sound. Okay, just a very basic class. Now if I want to create here dog, so dog is nothing but a animal. So instead of creating or writing the functionality for the dog, I'm gonna use my animals functionality. So just use here animal, because you want to inherit the functionality of animal in your dog. So to do that, you can use here open keyword. Similarly for the function, use here open keyword. Now your dog is nothing but an animal, and also dog has some sound, so simply use your sound function and override it. Now you can define the logic corresponding to your dog. So in this dog, instead of calling our parent sound, I'm gonna remove it and use here println function and call this dog barks. So this is for the dog. Next I'm gonna create here cat. Cat is also a animal, and also it makes some sound, so simply override the sound functionality, and this time I'm gonna print cat meows. Okay, dog has a different sound and cat has a different sound. Similarly I'm gonna create one more class. This is for the cow. So cow is nothing but an animal that has some different sound. Use here println, and in this println I'm gonna use here cow moose. So we have here three different classes: dog, cat and cow, and eventually these are nothing but an animal. So it's like, so this is you are someone's husband, someone's father, someone's brother. This is like that. Okay, so now it's time to use it. So for that I'm gonna create here function main, and in this main function I'm gonna create here dog. Now dog is nothing but an animal, so simply use here dog, and that's it. Now I'm gonna create one more object, or you can say cat. Cat is nothing but an animal, so I'm using here cat. Similarly we are having cow, and cow is nothing but an animal. Simply use cow to create an object of cow. Now this time when you are using dog dot sound, so it will bark, cat dot sound, it will meow, and cow dot sound, so this will moose, right? So when you execute it, here you can see dog barks, cat meows, cow moose. So now you are able to store the reference of your dog into a variable that is a type of animal. Similarly it goes for the cat and cow, because cat and cow are nothing but an animal, and due to that reason you can very easily store the instance of your cat into a variable that has a type of animal. So this is what polymorphism is. Now I'm gonna use the same thing with collections. So collection is something that we will discuss later in this video, but for the time being just be with me. I want to create here a list. Type of this thing is a list of animal. So a list of, because dog, cat and cow, both has the same base class, which is animal. Due to that reason, we can very easily store the instance of dog, cat and cow in this list, and the list type is animal. Basically, you can only store animal type in this list. As you already know, dog, cat and cow both are using the animal class. So animal is a base class, and due to that reason we can very easily store the reference of dog, cat, cow in our variable that is a type of animal. So let's create here few things. So I'm going to create here dog first, then I want to create here cat, and lastly I'm going to create here cow, and I'm going to use here loop. So we will discuss what is loop, just be with me. So it dot sound, and it will automatically detect that this sound will used for the dog, this sound will use for the cat, this sound will use for the cow, and corresponding to that it will trigger the function. Now when you execute it, you can see, so first three is for the functions like this, and last three, which is this one, is coming from this loop. So this is a profit of using polymorphism. You can store the reference of your objects into your variable that has a type of your base class. Now we are going to discuss collections in Kotlin programming. So for that, first I'm going to create a package, and the package name is collection, and in this collection I'm going to store my file, and the file name is collections. We have our main function in here. Now let's say you want to represent a list of integer. How can you do that? So for that we have here list of function, and this function eventually used to create a list of some type, I mean the same type. So I'm using here 1 2 3 4 5. Okay, basically this will give you the list of integer. Now if I want to print this list, simply execute it to see the list. Here you can see this is my list. Next we have set 1 2 3 4 5, and when you print it and execute this main function, see we have 1 2 3 4 5 and 1 2 3 4 5. So what is the difference between these two? Well, if I am using here 5 and similarly I am using here 5, and now when I execute it, as you can see, set does not allow duplicacy, but in the list you can see we are using 5 5, and eventually we are receiving all the elements. So this set is actually used when you want to use the unique values, then you can use set, and list is a very common way of creating list. Now if let's say you want to create key value pair, so how can you do that? So for that we are having here hash map. So you can create hash map with the help of map of function, and in this map of function you can pass your arguments. So as I said to you, we are going to create here key value pairs. So let's say in the key I am using here key 2. So basically we are mapping this key to a value, and the value is a value. Similarly, if you want to use any other string, so let's say I'm using here key 2, and I want to map this key 2 with value 2. Similarly, you can create hash map according to your requirement. Now I'm gonna print this thing to show you the hash map. Execute it. Here you can see key value, key 2, value 2. So if you want to create this kind of things, you can use hash map. So these are immutable things, so basically you cannot make changes into them, but we have mutable collections too. So let's see how we can make these things mutable. So for that, simply copy this stuff, paste in here, and I'm gonna call this mutable list. Instead of using here list of, you should use mutable list of, and that's it. Now these values are mutable. So first let me print this thing. Similarly for the set, I'm using here mutable set, and instead of using set of, use here mutable set of, and print this mutable set. For the hash map, I'm using here mutable hash map and use here mutable map of, and at the end I'm gonna print this thing up, mutable hash map. So when you execute it, the contents are pretty much identical, as you can see over here. Now I'm gonna make some changes because these list set of map of are mutable. So let's see how we can mutate this thing. So I'm using here mutable list, and when you are using your set and use the index, so in programming all the indexed will be started from 0. So let's say I want to set a new value to my first item of my mutable list. So for that I'm gonna point my first index, which is using this value, which is 0, and I want to change this thing from 1 to 12. Okay, so now it will eventually update the first index with 12 value, and when you execute it, now you can see this will become 12, 2, 3, 4, 5, 5. That means this list is mutable. Similarly, if you want to mutate your mutable set, you can simply use your mutable set. If you want to remove anything, you should use remove and pass the element. So let's say I want to remove the 1, and when you execute it, you can see we are not having here 1. Okay, and also similarly for our mutable list we are having a lot of functionality. So mutable list we have here a remove, simply pass the element to remove the element from your mutable list. Similarly, if you want to remove the first item, you should use here remove first. If you want to remove the last item, you should use here remove last. And if you want to remove an element on particular index, you should use here remove at. So these are the various functionality that we are having with our mutable list. Similarly goes for the mutable set. You can remove it, and also if you want to add something, you can simply use mutable set and just use add and pass your element. So it will add, let's say 34, and when you execute it, there we go, you can see over here 2, 3, 4, 5 and 34. Now let's say how we can play with mutable hash map. So use mutable hash map dot. As you can see, we are having a lot of functionality, like if you want to remove a particular key, you can do that thing with the help of remove function. Similarly, if you want to clear all of the information which present into your mutable hash map, you can simply use clear. And if you want to put information in your mutable hash map, you can do that thing very easily with the help of put all, and you can simply pass map. So it will put all of the information into mutable hash map. So it's pretty much same. The thing is, now your collections are mutable. You can perform extra operations. Now let's say you want to perform some operation with your immutable things. So for that I'm using a list dot. As you can see, we don't have any functionality. You just get the things, but you cannot change anything in your existing list. Similarly goes for the set and hash map. So set dot, as you can see, we don't have anything to use that will perform modification into your set. Similarly goes for the hash map. So this is what collections is. Now we are going to discuss the most important concept in object oriented programming, which is abstraction. So for that, first let me create here package. Package name is abstraction, and in this abstraction I'm gonna create here file, and the file name is also abstraction. Now let's say you want to represent a rectangle shape. So for that we'll use here a rectangle. Similarly, if you want to represent a circle, you should use this class circle. By using these objects, you can represent a rectangle and circle, but the common factor between them is shape. Rectangle is also a shape, circle is also a shape. That means shape is something which is abstract, which you cannot see, but the objects that have implemented the functionality of shape is very much touchable and feelable, like rectangle and circle. So rectangle and circle are going to use the functionality of shape. Now in this case, because shape is abstract, you cannot see or touch the shape, but the classes that are going to implement the functionality of shape is very much touchable and feelable. Now in this scenario, I'm going to create here an abstract class, and the name of this thing is shape. Now this shape is something which is abstract, which you cannot see, but the objects or classes that uses this shape will very much touchable and feelable. Okay, so this shape has one functionality which is very much sure for every shape will have, which is area. Now I want to make this area function available to the classes that are going to extend this shape. We'll write its implementation. So for that I'm gonna make this thing also abstract. Now if it is abstract, that means the classes that are going to use this shape will eventually write its implementation. So let's use it. So for that I'm gonna use here shape, and in this shape we have one abstract function naming area. Now if you don't want to use the implementation for this area, what you can do, you can make this class also abstract. Now you don't want to write any kind of implementation for this class, but this is not an abstract thing. We can touch rectangle, we can feel rectangle, it has properties, it has area. Due to that reason, remove this abstract, and now you can write area corresponding to this rectangle. So for that, use area and override it, and I'm gonna simply print here statement, and the statement is rectangle area. This goes for the rectangle. Now circle is also a shape, that means it uses the functionality of shape and calculate its area corresponding to their properties. Like we have radius, so if you want to calculate area you should use pi r square. So formula is different, everything is different, but area is common. Like area is also available for the circle, for rectangle, for octagon, for cube. I mean every shape that you are seeing in your nature have area. So I'm going to use here print ln function and simply print here circle area, and that's it. This is what abstract class is. By the way, this is a class, so if you want to use here primary constructor, you can use that thing very easily. Let's say I want to pass here integer variable a, and if you want to pass primary constructor variable a type of this thing integer, on that case here in your rectangle class shape just pass 12 or 13, whatever. It's totally up to you or what information you want, and you can use this variable in your function. So let's say I want to print here display. In this display I'm using print ln function and want to print a. So for that just use a. This is also possible. You can also create some natural function that doesn't have any keyword naming abstract and use this display into your shape. So after printing this rectangle area, I'm gonna use display. Now this display is present in our shape abstract class. Now it's time to use this rectangle and circle. So for that I'm gonna create here a main function, and in this main function I'm gonna create a rectangle. Next I'm gonna create a circle. Use circle to create a circle. At the end I'm gonna use a rectangle dot area. So print ln rectangle dot area. Also you can use your shape primary constructor variable using your rectangle, because rectangle is also a shape. Due to that reason you can very easily access the shape primary constructor variable here. So if you want to use that thing, you can simply use rectangle dot a, but I'm interested to calculate its area. Similarly, write one more print ln function and use circle dot area, and when you execute it, so as you can see in here we have rectangle area, we have 12, and this 12 is printed because of I'm using a display, and this display is eventually used to print variable a, and we are passing here variable a value 12. Next we have Kotlin unit. So Kotlin unit is printed because our function has no return type. As you can see, if you are going to see the area implementation, return type of this thing is unit, I mean nothing, and due to that reason we are going to see this Kotlin unit. After that we'll use circle area. Due to that reason we are going to see here circle area, and lastly the return type of the circle area is unit. Due to that reason we are going to see here Kotlin dot unit. Okay, so now let's see the profit or the plus point of using abstract classes. Now I'm going to create here list, which is a list of shape. So in order to represent a shape, you should use your angular braces and mention the type, which is shape. Now in this you can simply add your rectangle and the circle. Remove this print ln functions, and now I'm gonna perform the loop. So list for each, it will give me the first element rectangle, then the second element circle. So it dot area. Okay, and when you execute it, you can see a rectangle area 12, and 12 is coming because of this display that we are invoking in our rectangle area. Next we have circle area. So the plus point of this thing is you can very easily store the object instance of your rectangle and circle in shape, because shape is a base class. Due to that reason, you can very easily store the instance of your rectangle and circle in a variable which has a type of shape. Similarly goes for the circle. This is what abstract class is. We discuss one of the most important OOPS concept, which is encapsulation. So first let me create package, and corresponding to this package we have file. So encapsulation, and in this encapsulation package I'm gonna create a class, and the class name is Encapsulation. For time being, just create a file. What is encapsulation? Encapsulation said that all of your member variable that is present in your class is not accessible from outside of your class. This is what encapsulation said. And also, if you want to access those member variables, then you should create getters and setters. Let's see in action. So I'm gonna create here a class, and the class name is box, and in this box I will have variable for length, type of this thing is float, then we have variable for the width, then we are having height. Okay, so we have three different member variable in this box. Now I'm going to create here a main function, and in this main function I'm going to create an object of our box, and in this box I'm going to pass 111, basically unit box. Now if you want to access the length, it is very easily accessible with the help of box instance. So box.l, it is available. Similarly box.w, it is also available. Similarly height is also available. Now encapsulation said that this is not possible. You can expose your class level member variable via getters and setters. So to do that, first thing first, we should make all of our member variables private. So private, this is for the length, then we are having our width private, then lastly we have private height. Now let's say I want to access my height. It is not available because of this private access modifier. You can only access this member variable within your class body. So let's create a class, and now I'm gonna expose these variables via getters and setters. So for that I'm going to create a function get length. Return type of this thing is float, and this will eventually return the information of our box length. Similarly, I'm going to create one more variable which is for the width. Type of this thing is float, the return type of this thing is float, and it will return you the width. Lastly we have height, so I'm gonna create getter for our height. Return type of this thing is float, and it will simply return the information of our height, box height. Now instead of using h, now you can use get height, and this will provide you information regarding the height of our box. Now all of our variables, member variables, are encapsulated. You cannot access these variables outside of this class with the help of their objects. This is what encapsulation said. And also, if you want to update your member variables, for that you should create setters. So set length, pass the length that you want to set, and use your L. So this dot L, and update it with incoming length from this function. We have a problem, and the problem is because I'm using here val, this is immutable, so make sure to use here var, and instead of using this equals to, you can use your pair of parentheses, the function body, and in this function body you can put this logic that is used to reinitialize or update our length. And there we go. Now you can use box dot set length, and I'm gonna update this thing from 1 to 12f, and at the end I'm gonna print all of the things. So print ln, I'm using box dot length using get length function, and convert this thing into string. And lastly, once we perform updation for our box length, Again, I'm gonna write here a print ln function. Use your box dot get its length. Now execute your function. Okay, so here you can see first our box length is 1. Next we have updated it and now it will become 12. So this is what encapsulation is. It said that instead of exposing your class level member variable, you should create getters and setters to get this information outside of this class, and to update this information or member variable you'll use setters. So this is what encapsulation said. Now we are going to discuss what is data classes. Well, data classes is used to hold your data. This is their primary objective. I'm going to create here a data class. So you should create a data class by using a normal class. Just use data keyword in front of your class. Now it will become a data class, and I'm going to call this large box. And in this we have length of this large box, then we have width, and lastly its height. Type of this thing is float. What is the difference between data class and normal class? Well, the sole purpose of data class is to hold your data, and also it has by default some functions which is overridden. So we have one function which is equals. So let me override that equal function in our class box. This equal function is used to compare two different boxes. Let's say I'm having here box 1 and I'm having here one more box, and in this box we're gonna use 2f length, 3f width and 4f height. So we have here two box 1 and box. Now let's say you want to compare between these two, whether it is equal or not. So in this case you have to override this equal function, and in this equal function you should write your logic to compare. So let's say I want to compare these two boxes. On that case we should write logic to compare these two boxes. For the time being I'm simply return here true. That means if you are going to use here box 1 dot equals, eventually it uses this equal function, and when you are passing here box, always it will return a true, because I have written a logic and that logic has nothing but it will simply return a boolean true. And I'm going to use print ln to print this value. Now when you execute it, as you can see, it returns true. Now if I am returning here false and re-execute main function, it will become false. Okay, so by default it uses this equal function. Now what will happen if I'll create two large boxes and use the same functionality? So for that, here at the bottom I'm going to create the large box 1, and in this large box this is a unit box, so I'm using here 1f 1f 1f. Next I'm going to create large box 2, large box 2f 2f 2f. Now I'm going to use here print ln function large box 1 dot equals and pass the large box 2. Now as you can see, length is different, width is different, height is different, so it will return us false. Now here you can see false. Now if I'm using here 1f as length, 1f as width and 1f as height, now when I execute it, you can see true. That means this equal function is already implemented by our large box, even though we haven't override any equal function in this data class, but it is their functionality. It will provide you some facility, like it will automatically override equal function. We have hash code function. In this we have one more function which is hash code, and also we have one more function toString. So these three functions will be automatically implemented or overridden by our large box because it is a data class. This is a main difference between normal class and data class. The sole purpose of data class is to hold your data. What is interface? So for that, first let me create package, and the package name is interfaces. And in this interfaces, I'm gonna create a file, and the file name is interfaces. So what is interface? An interface in Kotlin is a blueprint of a class. It defines a contract that the implementing class must adhere to. Interfaces can contain abstract methods, concrete methods, and properties. So let's see in action. So let's say I'm going to create an interface and the interface name is vehicle. Okay, now in this vehicle, I'm going to define a function naming start. So this is an abstract method. Okay, so next I'm gonna define here one more function naming stop, and I'm gonna write its default implementation, and in this we have println and it will simply print stop. So basically we have two functions in this interface. As I told you, we have abstract method, we have default implementation method, and lastly you can also add abstract properties. So for that I'm going to use here name, type of this thing is string. Now this is nothing but an abstract variable. So this is my vehicle. Let's say I want to create car. So for that I'm having a car class, and in this car class I'm gonna use my interface. As I told you, an interface in Kotlin is a blueprint of a class. So I'm gonna use this vehicle blueprint in our car class. So use simply here vehicle, and we have a problem, and the problem is if you are going to use this contract or this blueprint, on that case you should use all of the functions, all of the parameter that is present in your interface. So we have here implement member suggestion. So simply click on it. We have two things, name and start. So we haven't see here stop because stop is already implemented. Due to that reason, we don't have to override the stop function in our car class. Now simply click on OK. So we have here two different things. We have here name variable, which is overridden. Next we have start function, which is also overridden. Now in this name, let's say my car name is desire, and my start function will eventually use to print start. Now let's say you are interested to override this stop function. It is possible. You can simply use your stop and override it. If you are using your super stop, what it will do, it will simply trigger this stop function which present in your vehicle interface. So I'm gonna leave this thing just to show you it is working. And lastly, I'm gonna use here println and call this desire stops. Right, so now I'm gonna create a main function, and in this main function I'm gonna create a car, and I'm simply using this car. So first I want to print its name. So for that we use here println car dot its name. Next I'm gonna use my car and start it, and lastly I'm gonna stop it. So what it will print? So first it will print desire, then it will print start, and lastly it will print. So first we have here super call super dot stop, so it will eventually go in here, print this stop, and after that it will print desire stops. Now execute it. See here, first we have name, which is of course desire, then we have car.stop will trigger. So first it will trigger its super implementation which is present on in our interface function. So it will print stop, and lastly my desire call stops. So this is what interface is. It is usually used to define a contract that your class will be implemented. Next we are going to discuss how we can create a singleton class with the help of objects. So let's get started with the coding. I mean, in the coding it's very easy to understand. So for that, let me go in my encapsulation, and in this I'm gonna show you how we can use objects and what is a use case of object. So I'm gonna create here an object, and the object name is counter. And in this object I'm having a variable, and the variable name is again counter. Initial value of this thing is 0. This object contain a function, and this function name is increment counter. So what it will do, it will simply use to increment our counter. So I'm having a counter and I want to update its value. So we'll take the previous value of our counter and simply plus 1 in it. So it will give us the, if we calling this function for the first time, it will use the previous counter value, which is 0. 0 plus 1 1, so it will automatically update this counter value from 0 to 1. And we have one more thing, you can also replace this whole thing with plus equals to. It simply means the same thing that we were writing initially. So we have an object naming counter. So corresponding to this, I'm going to create a class, and the class name is counter class. And in this we have a variable name is counter, initial value of this thing is 0. We have a function, and the function name is increment counter, and it will do the same thing. So counter plus equals to 1. Okay, so we have an object and we have a class. Now let's see what is the difference between them. So to show you the difference, I'm gonna use this main function. So remove all of the things, or I'm simply comment this thing out. And here I'm gonna use first the class. So for the class we have to create an object to access its function. So we have counter class, create an object with the help of counter class and a pair of parentheses. So now we have an instance of our counter class. Use counter class and simply increment its counter. And lastly, I'm gonna simply use println counter class dot counter. So what it will print? So logically it will print 1. Same I'm using for the counter. So if you want to access an object, you can simply use the object name. So my object name is counter, and simply I'm using this counter in here. Now this will contain a function naming increment counter, and what it will do, it will simply increase the counter variable which present in our object naming counter. And lastly I'm gonna use println and print my counter dot counter. Okay, so execute it. As you can see, 1 1. Cool. So now I'm gonna use the same object, this counter object, in my different main function. So for that let me use this interfaces, and we have here main, and in this main I'm gonna use my counter and perform the incrementation. Lastly I'm gonna print the value, so counter dot counter, and execute it. As you can see, we have 1 1. So what is the main difference between a normal class and an object? So the main difference between them is this counter act as a singleton. That means it has only one instance. So if you are going to increase its counter, it will persist. But in counter class, this won't happen, because if you want to access its member functions, on that case you should create an instance or an object of our counter class. But if you are going to access the object counter function, you don't need to create any kind of instance of the counter, because it is a singleton. Due to that reason, you can use this counter instance and access this member function. Now next we are going to discuss companion object. Now let's say you want the same behavior of your object within your class. Now, then in this situation you can use companion object. So companion object means public static final. So this will eventually act as an object. Now in this, if you are going to put all of this thing, it is now accessible using counter class instance. So for that, now we don't need to create any kind of object for our counter class to access its increment counter function. You can simply use the class name, and there we go. Now it act just like an object, because we are using a companion object. Due to that reason, this block will act as a singleton, just like our object do. Now it's time to see how we can access our counter. So simply use the counter class, and there we go. Now we can access it very easily, and when you execute it, we have 1 1. So execution wise nothing changed, but the main thing that we change in our class is we put all of our logic, our variable, in a companion object, because it's an object, the behavior of this particular block will similar to an object. And the main behavior of object is it has only one instance, and in that instance you can perform anything, it will persist. Discuss when to use object declaration and when to use companion objects. So first let's discuss the purpose of object and companion object. So the sole purpose of counter is to create singleton instance or only one instance. Whereas if you want to create static like members of a class, then you should use companion object, because now counter and increment counter will act as a static. What do you mean by static? Static means by using this counter class you can directly access this counter and increment counter. You do not need any kind of object to access counter and increment counter. So this is what is static like member of a class. That means you can access it from anywhere by using your counter class. I mean, not the counter class object. Just using this class name you can access the counter and increment counter. Next, if we talking about the scope means from where we can access this counter and companion object, member variable and function. So this is what scope means. So if you are having an object, so this is accessible from anywhere in your application. Whereas if you want to access companion object, then in this case you should use the class name. That means the companion object scope is defined and that scope is this class. You cannot access companion object, variable and function without counter class name. Due to that reason it is scoped to enclosing class, which is counter class. And the main purpose of this object and companion object in our Android development is, so mostly we'll use object when we want to create a utility class, shared state or singletons. Whereas companion object is used when you want to create any kind of factory method or you want to create any kind of constant that you are going to use within this class. So mostly static like behavior, if you want, you can use companion object within your class. I'm gonna tell you what is extension function in Kotlin. So normally we'll create function, let's say I'm gonna create here a function naming hello, and this hello function is only accessible via counter class object. Now I want to create the same function outside of this class body and that has this similar behavior like hello. How can we do that? Well, here come extension function. So just remove this function, and if you want to use extension function, what you need to do, you simply create a function, use the class name which is counter class, use dot and give the function name which is hello, and simply use your print ln and print some message which is hello world. Now this function will eventually act as this function. Okay, you cannot access this hello function without an object of counter class. So let's see how we can use it. We have an extension function. So extension function name is hello and this extension function uses counter class. Scroll down, we have here instance of our counter class. No, we don't have any. So let's create counter class naming instance. With the help of counter class you can create an instance of our or object of our counter class. Use counter class, as here you can see we have hello function. This hello function isn't present in our counter class body, but it present outside of this class body and it act as a normal member function which we'll have in our counter class. So this is the way of using extension function. So let's execute this main function to see whether it is printing or not. As you can see here we have hello world. So this is what extension function is. Now let's say I'm not using this object instance. It is not accessible because it is extension over counter class. So this is what extension function is. Now we are going to discuss one of the most important expression in Kotlin programming, which is when expression. When expression in Kotlin is a powerful and versatile control flow structure, similar to switch statement in other languages but more expressive and feature rich. When expression is used for conditional branching, it can very easily replace complex if-else chains. As you can see in here, we are using if-else chaining. We will see how we can replace this thing with when expression. But let's begin our journey with very simple example. So here you can see we have function check number. So check number will eventually check the past number whether it is positive or negative. So we are using here if else condition. Now I want to remove this if else and use when expression instead of if else. So first you can simply use here a when keyword and open a pair of parentheses. Now in this parenthesis you can write all of your logic that you want to use, and corresponding to that it will execute a block of code. So my logic is number is greater than 0. You can use here arrow. So this arrow will contain the logic that you want to write when this condition is true. So if it is true, as you can see here we are returning true. I am simply using here true. Okay, what happen if number is negative? So I'm using here else. Now else block will executed when none of your expression got satisfied. Here you can see if I pass here number negative, so this condition will be false. Eventually it jumps on the else condition. Now in the else I want to return here false. Now I want to return true false based on the condition, then simply use your return keyword just before your when expression or keyword. Now remove this thing or comment it out. So in our main function we are using here check number, as you can see in here. Now I'm going to execute it. So yeah, it is true because I'm passing here 12, and second println is false I believe because I'm passing a negative, as you can see. So when expression works. Now what you can do, you can use the same logic and just use when expression in isAdult function. Okay, so now it's time to tackle the complex if else chaining. As you can see in here we are chaining if, then else if, then else if, then else. Let's see how we can use when expression in this scenario. So for that I'm using here when. Okay, as you can see my first logic is marks is greater than equals to 90. So I'm using here marks and check if it is greater than or equal to 90. What I want to do, I want to print here grade is A. Okay, that means every marks that is greater than 90 will never come below to this block. Cool. Now I'm going to write the second condition. So as you can see, if marks is greater than 75, so we have here greater than equals to 75. In this case this piece of code will be executed. So I'm gonna use here println and call this grade B. Okay, so if marks is greater than 90 it falls in this block. If marks is greater than or equal to 75 it will execute this block. But if let's say marks is 95, it will only execute this piece of code, or you can say this block. It will never come onto this block. Cool. So I'm going to use here marks greater than or equals to 50. If it is the case, I want to execute this piece of code println, and this time my grade is C I believe. And lastly we have marks greater than or equals to. Okay, so we have only this condition. After that I'm using else. So similarly you can use here else, and in this else we are printing grade F, which is fail. So as you can see now we are replacing this thing with when expression. So we have when expression, and in this when expression we are writing logic. So if it is true then it will execute this block, or you can say in this particular example this line of code. Similarly if marks is greater than 75, in this case it will execute this piece of code. Let's say your mark is 85. Now 85, if you compare this thing up, 85 is not greater than 90, so it will simply check the next condition. 85 is greater than 75, yes it is, so it will print grade B. It will never check this condition because the condition is already satisfied by your upper branches. Cool. So now I'm going to execute this thing. As you can see in our main function, we are using this thing grade students, so just execute it. Okay, so 95 means grade A. 80 means greater than 75, so grade B I believe, as you can see. Then we have C, then we have D. Alright, so it is working. Now let's say I want to create one more function, and this time I'm using here print numbers. You have to pass number, type of this thing integer, and it will print the numbers in alphabet. So I'm using here when, and you can also use this small bracket and pass the number. And I want to use this thing when my number is 1. Why number? Why I am saying here number? Because in this small bracket number is present. So what when expression will do? Well, it will check the condition based on this number. So if our number is 1, on that case I'm gonna print here 1. If it is 2, it can simply print here 2. If it is 3, it can simply print here 3. Else I'm gonna say here not found. Okay, so now let's see how we can use this thing. So print numbers, and I'm using here 1, duplicate it, I'm using here 2, duplicate it, I'm using here 3, duplicate it, I'm using here 4. Execute it. So as you can see 1 2 3 not found. So when you are passing here number 1 in your print number function, so number 1 come in here, so it will check the number. So if number is 1, it can print 1. If number is 2, it can print 2. If number is 3, it can print 3. It's like that. So this is what when expression is, and I have covered everything that you should know regarding this when expression. Oops, I forgot the most important thing of when expression. So using this when expression, you can also check the type of your class. So just to show you, I'm gonna create here few class. So first I'm having here an abstract class, and the abstract class name is shape. Okay, so this is shape, and I'm gonna create a class, and the class name is triangle. Now triangle is a shape, so simply use the shape. Okay, similarly I'm having one more shape naming a rectangle, so simply use the abstract class shape, and yeah, there we go. And in our main function, I'm gonna create here 2 different objects. So first object is triangle, type of this thing is shape, and I'm gonna create here triangle. Similarly we have a rectangle, type of this thing is shape, I'm gonna use here rectangle type. Okay, so now I'm going to create a function which is actually used to print the triangle and rectangle based on their type. So for that I'm going to create here function, and the function name is print types. I'm going to pass my shape. Now in this case I'm going to use when expression, and in this when expression we gonna use our shape that we were receiving from this print type. This shape is of 2 different type. Either it is the type of triangle, so if you want to check the type you should use here is keyword. So is actually used to compare the types. So S is a type of triangle, like that. Next we have a rectangle. So if it is a type of triangle, I'm gonna print here triangle. Next, if it is type of rectangle, I'm gonna use here a rectangle, and now it's time to use it. So print types. So first I'm gonna use my triangle, and next I'm gonna use my rectangle. Execute it. So as you can see in here, first is triangle, second is rectangle. So by using when expression, you can also check the type as you can see in here. Now we are going to discuss enumeration and sealed classes. So what is enum classes? An enum is a special data type that defines a fixed set of constant values. It is ideal for representing categories or options where the values are known and limited. Let's see this with an example. So for that, first let me create a package, and the package name is enum and sealed. And in this enum and sealed, I'm gonna create a file, and file name is again enum and sealed. Okay, so first thing first, let's see how we can create a enum class. Because it is a class, so just use here class name, and I'm gonna name this class shape. Because it is an enumeration class or enum class, just use keyword enum before the class, and there we go. Now we have an enumeration class shape. Let's say this shape has information about the circle, so you can simply use your circle, and that's it. You can also use the next step, which is a rectangle, and lastly you should use here triangle. So this enumeration class shape has three different constants, so you can represent with the help of this shape enumeration class circle, rectangle and triangle. Now let's say I want to write a function which will give me the formula corresponding to this shape. So for that, I'm going to create a function, and the function name is area formula, and make sure the end constant of your enumeration class shape will have semicolon. If you don't give here semicolon, it will give you an error. As you can see in here, we have a problem, and the problem is you are not using here semicolon. So if you want to create any function within your enumeration class, just use semicolon at the end or the last constant. So these are constants: circle, rectangle and triangle, and triangle is our last constant. And in our last constants, I'm gonna use here semicolon, because next I'm going to create a function. So this function eventually return us the formula corresponding to our circle, rectangle and triangle. So for this, we use here when expression. So we will discuss what is when expression. So first I'm gonna pass the instance of my shape. So it has three different constant: circle, rectangle and triangle. So simply use your circle, then we have a rectangle, and lastly we have triangle. Okay, so this circle have formula, and the formula is area is equivalent to pi r square. So I'm gonna call this pi times r into r. So this is my formula for the circle. Next we have rectangle, so area is equivalent to width multiply by height. So this is the formula for rectangle. And lastly we have triangle formula. So area is equivalent to half, so 0.5 times base into height. So these are the formula corresponding to the shape. And lastly I'm going to simply return this thing and change the return type from unit to string. So we have a function naming area formula, and it will return me the area of circle, rectangle and triangle depends on the constant. So let's see how we can use this enumeration class naming shape. So I'm going to create here a function, and the function name is main. In this main I'm gonna use shape. Now I'm interested in the shape of circle. So now we have shape of circle, and I want to say its formula. So you can see it very easily. Simply use here println shape dot, we have a function naming area formula. And what area formula will do? Well, it simply checks the instance type. So currently my instance is shape dot circle. That means this will eventually use to represent this circle shape. So it will eventually go in this circle and check whether this instance is equivalent to this circle or not. Yes, it is equivalent to this circle. Simply it will return this area. Okay, so when I execute it, here you can see area is equals to pi r square. Now let's say I want to add one parameter in its constructor. So I'm going to call this description. So because we have a constructor and this constant will eventually represent this shape. That means this constant will also have the constructor. So simply use here small bracket and give the description. So I'm going to use here circle shape. For the rectangle, I'm using here rectangle shape. And lastly we have triangle, so simply use here triangle shape. So long story short, you can also use here constructor, and because this constant will eventually use to represent shape, due to that reason this constant will also have the constructor. Cool. So now let's use this description. So for that I'm gonna use again the println, use my shape dot description, and when you execute it, it will give you circle shape, as you can see in here. Now the problem with this enum class is you are not able to calculate the area of the circle. Yes, you can print the formula, but you are not capable of calculating the area, right? So let's see how you can fix this problem with the help of shield class. So for the shield class, I'm gonna use here shield class, and the shield class name is shape shield, just to make differentiator. Okay, so we have a shield class shape shield. Now in this you can define subclasses. Just like here you are defining the constant, in this shield class you can define subclasses. So I'm interested in a data class, and the data class name is circle. And because this is this data class present in our shape shield class, you should also extend your data class with shape shield. Okay, so now I want to pass the radius of our circle. So in its constructor you can simply use here radius. Type of this thing is float. So now our shape shield class has one subclass naming circle. I'm gonna create one more class, and this time I'm gonna represent a rectangle, because a rectangle has two things. First it had width, next it has height. Because it is a subclass, so simply use here shape shield. Next I'm going to create one more data class, and this data class is nothing but our triangle. And triangle contains two things. So first it has base and it has height. Type of this thing is float, and because it is a subclass of our shape shield, so just extend this thing with shape shield. Now I am interested to calculate the area of our circle, rectangle and triangle. So if you want to create a function in your shape shield class, it is possible. You can simply use here a function, and the function name is area. Now in this area again I'm gonna use here a when keyword, and in this when keyword you can simply pass your instance, or you can say current instance. So we have three types of instance, and we can check instance by using is. So is a keyword that is actually used to check the type. So because this is representing either circle, rectangle or triangle, so if this is an instance of our circle, so it will verify if this is the type of circle. Then what it can do, it can write the formula and calculate the area. Next we have a rectangle, and lastly we have triangle. So basically we have three different instances of our shape shield: circle, rectangle, triangle, and this will eventually represent any of them: circle, rectangle and triangle. So if this is a type of circle, will end up in this particular section, or you can say in this block. If this is a type of rectangle, we gonna execute this line of code, or if this is an instance of our triangle, we simply come in here and execute all of the logic to calculate the area, right? So let's calculate the area of our circle. Now in this I'm gonna use math.pi, so it will give you the value of pi, and simply multiply this thing with radius into radius. it will give you the area of our circle. So for the rectangle you can simply use its width, because now this is a type of rectangle, and as you can see rectangle has a primary constructor that has two different things, width and height, and due to that reason, because my instance is a type of rectangle, we will access these two variables. So simply multiply width and height, it will give you the area of the rectangle. Next we have triangle, so 0.5 f multiply by base into height, and lastly I'm gonna simply return it. So the return type of this thing is float. Alright, so we have a problem, and the problem is the requirement is float. As you can see requirement is float, but it will give us the double. So this pi will eventually give you double, so use to float to convert double value into float. And yeah, that's it, this will give us the area. Now let's see how you can use this sealed class. So for that, simply go to your main function, and in this main function at the end I'm gonna create a circle. Use circle and make sure this circle is coming from our sealed class. As you can see, Gaur, Himanshu, Kotlin course, enum and sealed dot shape shield. That means yes, it is coming from our shape shield. Now in this you can pass radius. So I'm gonna pass radius here 2f. Print ln, use your circle dot area, and when you execute it, it will give you the area. As you can see over here 12.56666371. Similarly, I'm gonna use here a rectangle variable to represent our shape shield dot rectangle. In this you can pass your width and height. So let's say width is 2f, height is also 2f. Print ln a rectangle dot area, so it will give you 4, as you can see in here. Lastly, I'm gonna use triangle. So shape shield dot triangle, pass your base which is 12 and height which is 4f. Make sure to use here float. Use print ln triangle, and there we go. And when you execute it, you can see triangle. Okay, sorry, so I'm directly printing this triangle. So as you can see, this is a data class. So data class has already implemented toString function, and due to that reason you can also see here triangle base height. So it will print all of the information regarding the data class. Now I'm gonna use here area, so it will calculate the area of our triangle. There we go, 24. So half into 12 into 4, 12 4 is 48, 48 divided by 2 equivalent to 24. So yeah, it will calculate the area of our triangle. So this is what enum and sealed class. So as I believe you have already noticed that shape shield is more flexible comparing to enum classes. So now let's discuss the use case of our enumeration class and sealed class. So enum class is mostly used to represent simple categories like states and modes. As you can see, we have three types of constants: circle, rectangle, triangle, and it will use to represent a shape. But let's say you want to calculate its area, it's very difficult. Although you are able to calculate it, but it will very difficult. You cannot pass values at runtime. So let's say what I was trying to say in here. I'm gonna use a radius. Type of this thing is float. So this radius belongs to the circle, but still this radius is totally belong to the circle. We have to pass this radius from all of our constant. So circle has radius, yes, it is true, but rectangle doesn't have any kind of radius, but still you have to pass it because it is defined in the constructor and you should follow the constructor. Triangle is also not have any kind of radius, but still you have to pass the radius. This is the problem with enumeration. Well, you can very easily represent triangle, rectangle, circle, but you cannot calculate its area. Yes, you can calculate, but the process of calculating this triangle area, rectangle area and circle area via enumeration classes are very tough. So please avoid these things in your enumeration classes. Yes, you can use these enumeration classes to define simple categories like state or modes. As you can see in here, we are using shape to define circle, rectangle and radius. You can represent these as a constant, but when it's come to area calculation, this won't work. You should go to your shape sealed, or you can say sealed classes. So sealed classes are usually used to perform complex type of operations. As you can see in here, this is a complex if we are comparing this shape sealed class with our enumeration class, but because we are using here sealed class, we have more flexibility. We can calculate our area very easily without having any problem. So when you are going to use enumeration class, when you have a simple predefined list of constant, then you can go with enumeration. And when you need flexibility to add unique properties or behavior for each type, then you should go with sealed class. You can see in here, in our shape sealed, we can have constructor, and we are not using this constructor. And if you want to use it, you can very easily just create a variable in your primary constructor. So let's say I'm gonna add one variable in my primary constructor naming description. So you can pass your description. Let's say I'm gonna use here circle, and here I'm gonna use rectangle, and lastly I'm gonna use triangle. Right, so let's use this thing. So in our main function, we are having a circle. Now let's say I want to print one more thing, circle dot description, and when you execute it, you can see in here, now we are getting circle. Now assume you don't want to use this primary constructor of your sealed class. On that case, I believe you don't use class. Instead of class, you can use interface. And there we go. Because this is an interface doesn't have any kind of primary constructor. So just remove it. And similarly, now you don't have to use pair of small brackets to use this shape sealed interface in your data class circle. So just remove it. Same goes for here, same goes for here. And yeah, we are pretty much done. So you can use interface when you don't have any kind of constructor parameter for your shape sealed class. So here you can see we don't want to pass any kind of description. Due to that reason, I'm changing my class to an interface. Now come in here, as you can see, we don't have any kind of description in our primary constructor, and also our shape sealed class will now become an interface. Remove it and execute it. It works. As you can see in here, everything is working. So yes, you can also use sealed interface instead of sealed class. We are going to discuss try, catch and finally block in our Kotlin programming. So let's say we have a class. So first let me create here class. So for that I'm gonna create a package, and the package name is try catch finally. And in this try catch finally, I'm gonna create a file, and the file name is try catch finally. Okay, so in this I'm gonna create a function, and the function is actually used to divide numbers. So I'm gonna pass here my first number, which is a, and I'm gonna pass my second number, and the return type of this function is integer. Now if you want to divide two numbers, what you can do, you can simply use here a/b, so it will do the dividing things. But we have a problem in here, and the problem is, let's say some person sends this b 0, then what will happen? As you can see, if you divide any number with 0, it will eventually give you infinity in terms of mathematics, but it is not possible. I mean, you cannot divide some value with 0, right? So if you are going to do this thing, it will eventually throw an exception. So let me show you that exception. So function main, I'm gonna use here divide number 1 divide by 0, and when you execute it, as you can see, we have a problem in here, and the problem is exception in thread main. Divide number try catch finally, so it will also point me where is the problem, and the problem is in here line number 4, and the problem is you cannot divide any number with 0. This is the problem. So to prevent this kind of crash from your application, what you can do, you can wrap the logic with try, put this information in here. Now this will sometimes throw an exception. So if it will throw something, we will catch it. So let's catch it. And this type of exception is called arithmetic exception because it is related to the arithmetic operation. That's why. Now here I'm gonna print ln. So basically I'm gonna print something and exception caught. So yes, we are caughting exception, and eventually I'm gonna return the 0. So basically if you are going to divide anything with 0, it will return 0. Use a return just before your try keyword. Now this time when you executing it, it will never crash your application, and instead of crashing your application, what it can do, this will throw an exception, and the type of exception is arithmetic exception. Because it will throw an exception, we'll catching it, and exception caught. There we go, exception is caught. Just control click on this arithmetic exception. So basically we have a lot of exception, as you can see in here: arithmetic exception, number format exception, null pointer exception, unsupported type exception. So we have a lot of exception, and the most common exception that you will see during your Android career, which is this exception. This is exception which is mostly very commonly used. Okay, so I guess you got the idea of try catch block. Now let's say you want to execute some code after this exception will be thrown by your try. So for the time being, it will throw an exception, we'll catch it. But I want to also print some extra information, and I want to be certain that that information must be printed. So for that you can use here finally, and in this finally just use println. So finally block will execute, and it is must. I'm gonna use here finally block, and now when I execute it, as you can see, exception is caught, finally block is also triggered. Now what will happen if I use here 1? As you can see, because this time it will never throw any kind of exception, so it will simply return the result of this. And finally block is the most important part of our try catch. It will execute anyhow. So here you can see finally block is also executed. Now I'm going to print the output from this divide number function. As you can see, finally block will trigger every time. It doesn't matter whether you are getting any kind of exception or not. In both cases, this finally block will trigger. So you can write your code in the finally block which you want to be execute for sure. This is what try catch finally block is. And also you can add here multiple type of exception. So let's say for the time being we are catching only the arithmetic exception. Now what will happen if I want to catch normal exception? So yes, you can do it very easily. Just print here normal exception. So normal exception and return here 0. By the way, if you want to throw exception manually, you can do that thing very easily. So instead of this logic, I'm gonna comment this thing out, and I want to throw exception of type exception. So for that you can use here throw, and my type is exception, and I'm gonna send message to, and the message is exception or manual exception. Okay, so now when you execute it, as you can see, this time because I am manually throwing exception, type of this thing exception, and in our catch this is the particular block that will catch this type of exception. So it will catch it and it will print normal exception. After that it will print the finally block, and there we go. Lastly the answer, because I'm returning here 0, so answer is 0. So by using this throw keyword, you can actually throw manual exceptions too. Now we are going to discuss Lateinit and lazy in Kotlin programming. So these two are the most important and most interviewer favorite questions. So most of the interviewer ask you what is the difference between a Lateinit and lazy. So let's see what is the difference between them and how we can actually use to make our programming journey more smooth. So for that, first thing first, let me create package, and the package name is lazy and late init. So this is my package name, and in this package I'm gonna create a file, and the file name is, basically it is a class, and the class name is user. In this user I'm having here late init variable. So late init keyword is actually used when you want to create any variable and you want to reinitialize your variable again and again during your program execution lately. That in this scenario you can use late init, and this variable is also representing a variable which is mutable, so you can also change this variable again and again. So late init is usually used when you want to initialize your variable lately, because it is a variable, and this late init keyword is only usable with variable var. You cannot use this thing with val, as it is already saying that this variable is initialized lately. So if you want to initialize your variable lately, how you can use your variable? If you are using here val keyword, that means it is not changeable or not mutable. So combination of these two is not possible, so you have to use your variable. Let's say I'm having here first name, type of this thing is string. So we have a latent variable that will be initialized lately in our program execution, and I'm having a function, and the function name is initialize first name. Pass your name, type of this thing is string, and it will eventually update our first name. So this is possible because it is a variable, and also we are mentioning it here. This is a late init variable, that means it will initialize lately in future during our program execution. Next I'm going to show you how we can use lazy block. So lazy block is used with val keyword because it is not a mutable variable. It has only one single value, and I'm gonna call this last name. Type of this thing is string. So usually we use lazy with by keyword because it is initialized lately. So we have here lazy, and the last name of person is Gaur. Now this main difference between lazy and latent is, so few difference I have already told you. Now the most important difference that I will tell you in here is lazy block will only initialize when you will access the last name for the first time in your program execution. I repeat, lazy block is used to initialize your variable when you will access your variable last name for the first time in your program execution. If you are not using this last name during your program execution, it will never allocate any kind of memory to this variable. This is the main difference between Lateinit and lazy block. Cool. So now I'm gonna use here function which is actually used to print the name. So first thing first, we need to check whether the first name is initialized or not. So for that I'm using here 2:, use your first name, and in this we have one property naming is initialized. So if it is initialized, on that case I'm gonna use here print ln and simply print my first name and add my last name. So here as you can see, we are accessing our last name. This is the point at which your last name got initialized by Gaur. Okay, so else if it is not the case, I'm gonna simply print here name is not initialized. That's it, or just add yet. Okay, so this is the main difference between latent variable and lazy keyword. So latent variable is actually used with var, lazy is used with val. This is mutable property, this is immutable property. This lazy block will only initialize the last name when you have been access this thing for the first time in your print name. Okay, so enough talking, let's get started and see how we can actually print those names. So for that I'm going to create a function naming main, and in this main I'm having a user. Okay, so user dot print name. So if you are using this function before initializing your variable, eventually it will print name is not initialized yet, as you can see in here. Now first I'm gonna initialize my first name. So user dot initialize first name, and first name is my name, which is Himanshu. Now when I'm executing it, there we go, Himanshu Gaur. So this is the main difference between latent variable and lazy block. Okay, so when do we use lazy block and when do we use latent variable? So latent variable, as you can see, is used when you want to mutate your variable again and again during your program execution, and also you want to initialize this particular variable lately. Whereas this lazy block is used when you are having a bulky object. Instead of creating that bulky object instantly, because those bulky objects require high amount of memory. So what we can do, we can use lazy block and we can only initialize that bulky object when this variable being used for the first time. By doing this, memory is optimized very well, because you cannot allocate memory to that bulky object initially. You are going to allocate memory to our bulky object only when you have access this variable for the first time. This is also a plus point of using lazy block. We will discuss loops in Kotlin programming. So what is loop? A loop is used to iterate over a sequence like a range, collection or array, and perform operations for each element. This is what loop is, and in Kotlin we use for loops. So let's create a package, and the package name is for each. In this for each, I'm going to create a file, and the file name is again for each, and in this file I'm going to create a main function. So function main. Now I want to create a loop in here. So if you want to get a loop, you can simply use here for, and in this for I'm using index I to represent my index number, and I want to iterate a loop which will start from 1 and goes up to 5. And lastly I'm gonna use here println and simply print I, convert this thing into a string. And when you execute it, you can see 1 2 3 4 5. You can play with this number. Let's say I want to execute this loop from 1 to 10, and when you execute it, you can see 10 loops which will start from 1 and end up with 10. So you can create loops like this. So now I'm gonna explain you how you can use step and down to keyword within your for loop. So for I in, so let's say I want to begin my for loop journey from 10, and I will go down to 1, and in its step I'm gonna just use 2 steps. So basically it will start from 10, then it will give you 8 6 4 2, and that's it. So let's use here println and simply print I, and when you execute it, as you can see 10 8 6 4 2, because the step is so it will jump from 10 to 8, then 8 to 6 4 2. So this is also a way of using your loops. Now let's say how we can use these loops in array. So I'm having a array of strings. So we have here apple, we have here banana, we have here cherry. So we have 3 elements. Now I want to perform iteration in this array. How can you perform it? Well, it's very easy with Kotlin. You can simply use fruits and just type for. You will have a ton of options. So for each will eventually give you one by one element. Println and print the values of that element. Just remove this thing, and when you execute it, apple banana cherry. Let's say you want to use index 2. So for that we have one more option for each index, as you can see in here. So first parameter will actually represent an index, and second parameter will actually represent your fruit. Use println, and here I'm using the index, and corresponding to this index we have fruit. Now execute it. By default index will start from 0, that's why we have here 0, which is apple, 1 represent banana, 2 represent cherry. And this for each index and for each loop will also work with list of. So instead of having this array of, if you convert this thing into list of, still it works. Okay, now I'm gonna use here set of, still it works. Okay, so now let's say I'm having here hash map, so I'm gonna call this map map of, so 0 index will have apple, first index will have banana, and last but not least this second index have cherry. Now let's say I want to iterate in this map. How can we do it? Well, you can do that thing very easily. So for that you can use for loop, and in this for loop, first I'm gonna use my index from my map, and next is our actual value in the map. So this is called object destructuring. So each map will contain two things. We have index and we have value. So index will be initialized in this variable and value will be initialized in this particular variable. Now let's say I want to print this thing. So first I'm going to print my index, and index will map to my value. So execute it. Okay, so I'm gonna remove this thing just to show you it is working. There we go, 0 apple, 1 banana, 2 cherry. Next we are going to see break and continue keywords in for loop. So for that just remove everything, and here I'm gonna create one loop which is started from 1 and goes up to 5. Now if our I is equivalent to 3, on that case I want to break my loop, so just use your println 3, and after that I want to break this loop. So println, and here I'm gonna use my index. Okay, so when you execute it, 1 2 3, so if I is equivalent to 3, it comes up in here, and once it reaches in this particular block it will break the loop. So once it will break the loop, it will never print the other indexes like 4. So here you can see it won't print the 4 and 5 because we are eventually breaking up my loop. Now let's say I want to skip my third iteration. So you can do that thing very easily by using continue. So when you execute it, you can see in here we are having 1 2 3 4 5. This is because I'm printing 3. Now I will remove my println function. As you can see in here 1 2 4 5, we are not able to see 3. This is because when our I value is 3, it will simply skip that particular iteration. So continue with the fourth value. Due to that reason we are not able to see here 3. So this is the for loop in Kotlin programming. Now we are going to see generics in Kotlin. So what is generics actually? So let me create a package and file, and in that file I will explain you what is the use case of generics. So I'm using here generics naming package name, and in this package I'm gonna put my file, and the file name is generics. Okay, so let's say I have a class and the class name is intbox. So we have value. Let's say type of that value is integer. Now I'm having a main function, and in this main function I'm gonna build my integer type of box. So int box, and my value is 34. Println. So I'm using my int box and I want to print its value, just stringify it. Okay, so when you execute it, it's very easy. We are going to see here 34. So we have an integer type of box that has a value as a primary constructor. Now I want to make this class generic. For the time being, it is a type of integer box, and I want to make this box generalize, so that if you want to pass integer in your primary constructor, you can pass integer If you want to pass a string, you can pass it. If you want to pass float or double, you can very easily pass it. So how we can do it? So to do that, first thing first, I'm gonna remove this int prefix from my box name, and we have to make this class generalized. So in order to make this class a generic class, we'll use here angular brackets, and in this angular bracket we have to mention the type. So it is a generic type, so I'm using here type T. Now this class will become a generic type class that has a type T, and I want to use the same type as a type of our value, so simply use here T. Now this T is recognizable because you have mentioned in here that your class is not a normal class, it's a generic class. Due to that reason, you can access this type T in here. So now your class become generic class. Now you can use this class with integer, with double, with string. I mean every primitive data type you can use in here. So okay, so now I'm gonna use here box, and in this box I'm gonna use the type integer and pass the value 34. Now let's say I want to pass here string, so string box mention the type which is string, and in this I'm gonna use string box. Similarly, I'm gonna use double box. You can use box within this angular braces, you can use double, and in place of double value I'm using here 1.23 something something something, and lastly we have our float box. So box type of this box is float and pass here 1f. Okay, and one more thing, because you have mentioned here float, and if you are trying to pass here integer, it will also give you an error because this type and the value type is same. As you can see in here, type is T and the same type is used in here, which is T. So if you are using a float, that means the value that you have been passing in your constructor is also be a float. That's why you have a problem, and simply use your float value, so it will remove the problem. Now let's say I want to see all of the results. So println, so first we have integer box, and corresponding to this we have integer box value. Similarly, we have println string box, and the value is string box value. Duplicate it. So after string we have double, and use here double box, and lastly we have float box and use here float box. And when you execute it, here you can see int box, string box, double box, float box. So this is the way of using generics in your classes. Now let's see how we can use generics with functions. So I'm gonna create a function which is a generalized function. So if you want to create a generalized function, on that case, after the fun keyword you have to mention the generalized type. So I'm using here type T. By the way, you can use here W, you can use here Q, it's totally up to you. I'm using here T just to make the things very simple for you, that's all. Okay, so because this is a generic function, we have to mention the generic type which is T. Okay, now I'm gonna give the name of my function which is print box content, and in its parameter I'm gonna pass my box. And because I'm using here generalized approach, or you can say I'm gonna use a generic function, so this generic function has a type T, and now it's time to use this type in here. In this function I'm gonna use println, and in place of the message I'm using here the box contains the value, so use your box value. Now instead of using all of these println statements, I'm gonna use here print box content and pass my integer box. Duplicate it, I'm gonna copy this string box name, paste in here. Similarly for the double box, similarly for the float box. Okay, and when you execute it, it works as you can see in here. So if you want to create a generic function, so first just use fun keyword. After that you have to mention the type. As you can see, I have mentioned in here type is t. Print box content, and I'm passing a generalized box. Due to that reason I'm using box as my parameter name, and type of this thing is box, type is t, which is generic. And lastly I'm simply using a println function to print the box value. Now let's see how we can use more than one type in generics. So for that I'm gonna create a class, and this time I will call it pair of box. Now because this is a pair, so pair contain two things, key and value. So key will be represented with k, value is represented with v. So basically we have two different types. So first we have key, type of this thing is k. Next we have the value, type of this thing is v. So it's a very generic class. Type of this thing is k and v. K represent key, value represent v. Now I'm gonna use this pair box. So for that, in my main function I'm gonna create my first pair with the help of pair box, and in this pair box I'm gonna mention the name, and the name of value is Himanshu. So this is my first pair. Next I'm gonna create one more pair which is for the age. So age pair, we have here pair of box that has age, and the age is 23. Okay, so we have two different pair and age pair. Now it's time to use print. So println function, first I'm gonna use key, so pair dot key. Next we have corresponding to this value, so use pair dot value. Similarly in here I'm using println, first we have key, just use your age pair dot key, and lastly its value, type of, and the value of this thing is age pair dot value. Okay, let's see whether it is working or not. Okay, so as you can see, key is name and value is Himanshu for the first pair, which is right. Next we have key is age and value is 23. So yeah, everything is working. Now we are going to discuss the constraint with generics. So for that, let me create one more class for you, and the class name is number of box. Type is t. Because we have number box, this type must be strictly constrained within the numbers. So type of this thing is number. So this type is only available to use integer, basically type of numbers we have in our Kotlin programming. Use here value, and type of this thing is t. Let's see how we can use this number box. So at the bottom I'm gonna use here int number box, and in this number box we will pass integer value which is 1. Next I'm gonna use the float number, and just duplicate this thing, I'm gonna use here double which is 1.0, and lastly I'm gonna use here string box. So because it is a number box, we cannot use here strings. As you can see, we have a problem, and also just use here string 1. Okay, so we have a problem, and the problem is because we are restricting this type only with number. So you can use here only numbers, but you cannot use here strings, but we are trying to use here string, and that's why we have a problem. Requirement of this thing is of type number, but it actually found string. This is a problem. So by using this approach, you can actually restrict your generic. Okay, so now it's time to print all of the things just to show you whether it is working or not. So int number value, duplicate it, use the float number, and lastly the double number, and simply execute it. As you can see, 1, 1.0, 1.0. So yeah, it works.